Hello friends, welcome to Risingpearl.com. This is series 7 where we're learning a great deal on quadratic equations. This is webisode number 4. Today friends, we are going to talk about solving a quadratic equation. Now you may find this strange, but first and foremost friends, I hope that you're following us along. In webisode 1 we talked about what is a quadratic equation, and more importantly, why do we even need quadratic equation. We looked at 2 or 3 examples as to when we were trying to solve them. We ended up getting what we now know is a quadratic equation, right? We have not really seen how to solve them just yet. In webisode 2 we looked at what do we mean by standard form of a quadratic equation. Webisode 3, which was the last webisode, we looked at some of the very basic types of quadratic equation questions. Sometimes the equation may look like a quadratic equation, but till you put the equation in the standard form, you will not know whether it is or is not a quadratic equation. So now, what do I mean by talking about solving a quadratic equation? So friends, let's write a quadratic equation. So here, I have written a quadratic equation like this, right? It is x squared minus 2x plus x squared minus 2x minus 3 equals 0. Now, clearly this is a quadratic equation because this equation is written in a standard form. Standard form of writing a quadratic equation is ax squared plus bx plus c equal to 0. We have seen this in the last webisode, where a is not equal to 0 and a, b, c are all real numbers, right? So, and here x is raised to the highest power 2, so this is a quadratic equation. Now, when we talk about solving a quadratic equation, what do we really mean, right? So now let's say if I were to ask you, let's put x equals 0, see what happens. So if you take the value of x equals 0, and if you put that on the left hand side, I'm not writing it the left hand side, L means left hand side. So you have, instead of x you put 0 minus 2 times 0 minus 3. Or this is 0, you get minus 3. And the right side, okay, let's write that by r. R is the right hand side, is 0. Or the left hand side is not equal to the right hand side for x equal to 0. How about x equal to minus 1? For x equal to minus 1, the left hand side will be, so this is minus 1 square, right? Instead of x we are putting minus 1, so minus 1 square minus 2, which is this minus 2, times minus 1 and minus 3, which is this one. So now minus 1 square is 1 because minus minus will become plus and 1 square is 1. Minus 2 times minus 1 is plus 2. And minus 3 is here. 1 plus 2 is 3 minus 3 is 0, which is actually indeed equal to the right hand side. So the left hand side value is equal to right hand side value for x equal to minus 1. So this is an interesting observation. Now similarly, if you take a look at how about we look at x equal to 2. See what happens at x equal to 2. So the left hand side value will be 2 square, right? X square minus, we have our 2 this one, and x is 2 minus 3. So here 2 square is 4, minus 2 times 2 is minus 4, and we have minus 3. So 4 minus 4 is 0, but you have minus 3. So the left hand side is again not equal to right hand side. How about for x equal to 3? And I'll tell you in a moment why we are kind of randomly picking all of these values and trying to find out what is the left hand side, what is the right hand side. So just bear with me for a moment. So for x equals 3, the left hand side is equal to 3 square minus 2 times 3 minus 3, right? 3 square is 9, minus 2 times plus 3 is minus 6, minus 3. Now this will be 9, minus 3 minus 3, minus 6 minus 3 is minus 9. So 9 minus 9 is 0, which is equal to right hand side. So what we see is that for this value of x equal to 3, left hand side becomes equal to right hand side. So whenever we actually talk about solving a quadratic equation, right, what we really mean is that we are trying to find these values of -1 and 3 in this case that actually satisfy the equation. Meaning when we say that we solve a quadratic equation, it means that we are trying to find those two values for which the equation will be true. So solving a quadratic equation really means that finding the values of x that satisfies this equation. So just the same way, if you were to think about, if I had to take a linear equation 2x plus 3 equal to 0, and if I were asked to solve this, so I know that what we will do is we will say 2x equal to first minus 3, or x is equal to minus 3 by 2. We will divide both sides by 2. So then we know that this value minus 3 by 2, if you put it in here, left hand side will be equal to right hand side. That means this value will satisfy this equation. So similarly, it's exactly the same for quadratic equation. When somebody says solving quadratic equation, all it means is we are trying to find out the value of the variable x that satisfies our given equation. So now friends, some of the other terms that are kind of important here these terms they go along with it, is in general a real number alpha, this is actually alpha, is called a root. It's a new term, for the first time we are actually talking about root. In general, a real number alpha is called the root of a quadratic equation ax squared plus bx plus c, where a is not equal to 0, if alpha, when you put the value of alpha in this equation, so ax squared becomes a times alpha square, and instead of bx we are putting alpha, b times alpha plus c equals 0. So which is exactly the same as what we saw earlier. That means if our quadratic equation is written in the standard form ax squared plus bx plus c equals 0, so if alpha is such a value that when you put it, it satisfies the equation, that means a alpha squared plus b alpha plus c will be actually equal to 0, then we say that alpha is a root of the quadratic equation. Meaning alpha is one of those two values that satisfy the equation. We call it a root of the quadratic equation. We also say that x equal to alpha is a solution of the quadratic equation, or also alpha satisfies the quadratic equation. I'm just trying to bring in all these terms at the same place so that you can clearly see through this. So basically what it says is, if we are given a quadratic equation ax squared plus bx plus c equal to 0, then if we find such a value, when we find such a value x equal to alpha, such that when you put the value of alpha in place of x, and if ax squared plus bx plus c, or a alpha squared plus b alpha plus c indeed is 0, that is left hand side becomes equal to right hand side, that means this is a solution of this equation, and we also say this is a root of the equation, right? Now for those of you who are following us along, also recall friends, in series 5 we have learnt about quadratic polynomials and zeros of quadratic polynomials. So if you recall, zeros of a quadratic polynomial ax squared plus bx plus c, we know that a standard form of writing a quadratic polynomial is ax squared plus bx plus c. So if you think about zeros of a quadratic polynomial, that is, if you recall when we looked at, I'm going to provide these video links below as well for your quick reference. if you recall that when we draw those graphs of a quadratic polynomial, wherever the graph cuts the x-axis, those are the zeros of a quadratic polynomial, right? So, and those zeros, they basically make the value of the polynomial 0, correct? So for example, if I say that let's say that x equal to k is a 0 of a polynomial px, it means that the value of the polynomial at k is 0, which is exactly the same thing, right? So in other words, 0 of a quadratic polynomial is the same as the root of a quadratic polynomial. They are one and the same thing. So again, I just wanted to make sure that we have a webisode where we talk about all of these various terms and how they all really mean one and the same thing. So we know that a quadratic polynomial can have at most 2 zeros. At most 2 zeros. This is also something we have seen earlier from our webisode, from our series 5 on polynomials, when we were talking about the graphical representation of a quadratic polynomial and the zeros of a quadratic polynomial. So from here it also means that any quadratic equation can have at most 2 roots, because really roots is equal to zeros of a polynomial, right? So the roots, if you can just simply replace the word zeros with roots, they mean one and the same thing. So we have seen earlier, and I think why don't we see if we can actually recall some of this. So if you remember, if let's write a polynomial, quadratic polynomial in the standard form. So if the value of a is greater than 0, then that means our graph will look something like this. It will be either this, right? It can be this, it can be this, or it can be this. Meaning that if you have a positive, right, the coefficient a, that is coefficient of x squared, if a is positive, the graph actually, it faces upward, right? It faces upwards. Now it can either cut the x-axis or intersect the x-axis at 2 points. It can intersect the x-axis at 1 point, or it does not intersect the x-axis. So in this case, there are 2 zeros for this polynomial. That means there will be 2 roots of this equation if this were to equal to 0, right? So if ax squared plus bx plus c equal to 0, there will be 2 roots here. In this case, there will be only 1 zero of this polynomial. There will be only 1 root for this particular quadratic equation, and here there are no zeros, and there are no roots of this particular quadratic equation. And similarly, if we were to write the same quadratic polynomial, except this time if the value of the a is negative, right? In this case, if we see that if a is negative, then our graphs, again recall, we have seen this earlier from series 5, our graphs of the quadratic polynomials will all be looking downwards. And even in this scenario, it can have 2 zeros, like in this example there are 2 zeros. That means 2 roots of this quadratic equation. Here there is only 1 0, so 1 root, and here there are no zeros, so no roots for this quadratic equation.